And I'll set a little context, introduce myself, and then go over something that my company Hiro made a big bet on that is really exciting and is deeply related to building on Bitcoin. And it's supporting developers who are building this brand new, newfangled layer on top of Bitcoin called Ordinals. Ordinals theory laid out by Casey Rodimer sometime late last year, early this year. And we had a couple of developers create some, frankly, incredible tooling that I think rivals the state of the market today, and it's not known about. So we're going to go over that in just about 20 minutes. So first, I'm Max, developer advocate here. I've been here for a little over a year and a half now. My story with Bitcoin is that I bought it when it was very, very low, and then sold it shortly thereafter, and actually thought I was a genius, and came to find that that was one of my one of my lower moments. I called it my $40 million summer. Since then, I've come into, like many of us, a total re-understanding, reorientation to Bitcoin, and I find that it's no longer a triviality, and that we are building a lot on it. And in fact, Ordinals represent a new way of interacting with this permanent, consensus-based, immutable data structure that we call blockchain. And Hiro makes incredible tooling for Bitcoin and stacks. So come check us out. A lot of you folks have heard about SBTC. There's a ton going on with Hiro supporting developers building on that. And today it's going to be about Ordinals. So Ordinals, I'm sure if you have anything to do with Bitcoin, you've heard about it. And you might not know this, or you might, that it's, Ordinals was not, Bitcoin was not built for Ordinals, which has like pretty powerful ramifications. It is a social convention. We agree that the order in which Satoshis are minted on the blockchain, and then we include some data alongside that Satoshi, that the two are interrelated. But otherwise, there's no reason that Bitcoin was built, it wasn't built with Ordinals in mind. And that makes actually working with Ordinals extremely difficult. For a couple of reasons. Getting reliable data is hard, chiefly because of this thing that the Bitcoin blockchain does, which is known as a reorg, where for some moments, maybe longer, some hours, the network is not actually converged on a consensus of what the chain tip is. So two blocks are mined simultaneously, and for a little bit, we actually don't know what's going to be the canonical chain tip, and therefore what is going to be valid, what are these transactions. And this phenomenon breaks most indexers on the spot. We've had the main indexers and the explorers of inscriptions break for hours or days. Also, relevant data, there's 520 gigabytes of data on the Bitcoin chain state. Hardly is all of it relevant for most use cases. So how to get just narrowly tailored slices of data can be its own challenge. And then again, Bitcoin isn't Ordinals first, so we find that when folks are looking for information or data, they're trying to guess what is a convention, and it may not be very intuitive. Okay. So enter Hiro tooling. I'm going to go over three pieces of Hiro tooling, which actually all build on top of one another. And right now here they're listed in order of developer friendliness. So the Ordinals Explorer is a great blockchain explorer built specifically for Ordinals, and it uses our API, which is a set of endpoints so that developers and users can query all of the most relevant Ordinals inscription data. But all of this really kind of boils down to the most powerful tool, the one I'm most excited to go over today, which is Ordhook. Ordhook is a reorg-aware client indexer built on top of Bitcoin and for Ordinals. And I'm really excited about it because it is not only faster in some respects than current state-of-the-market indexers, but it also is reorg-aware and resistant, something that I don't believe any other client indexers provide, and so there's a way to actually work with this, the nature of blockchain data in a more reliable way. And then also, you can get started much faster with this tool. You don't actually need to index the entire chain state, which might take for some of these other client indexers weeks or a month. You can actually, Hiro maintains archives that you can download quickly and get started in a matter of minutes building, which as a developer, when it comes to developing quickly is, there's no alternative. Once you know it could be done quickly, you don't want to do it another way. So again, I mentioned it's a reorg-aware client indexer. It's fast. You can get started in a matter of minutes or hours. And reliable. It's completely open source. So you can inspect what it is that you're working with. And it's also powering all of our other tools. We stand behind this software. OK, so let me give a quick demo of Ordhook. And for folks that might be following along, I am actually just following some of our documentation after downloading this open source tool. And I'm going to be sharing my screen. I know this might be a little hard to see, but I'm curious, does anyone recognize what is up top here, this very top panel? Does anyone, raise your hand if you recognize what that is. Cool, some of you. It's really tiny. I know it's, I'm trying to get everything on here. It is a instance of the Bitcoin daemon. So this is a Bitcoin node. And it's actually running in terminal. It's not running with the graphical user interface that most of us are familiar with. And what is powerful about Bitcoin D, or Bitcoin daemon, is that it can expose some more networking options so that we can interface with some of our Bitcoin data in like a faster programmatic way. My node is fully synced. You'll see here I'm still working. I'm connecting to other peers. And every few minutes, or every 10 minutes, a Bitcoin block appears, rich with inscription data. OK, and I'm going to minimize this. And then I have two other terminals. I'm going to be working with Ordhook, which is the name of this tool. And I'm going to be showing two primary things, scans and services. So an Ordhook scan is a fast way to just look up some inscription data. Right here, right now, I can inspect it visually, and then also I can deliver the payload that Ordhook creates, deliver it to some, well, either to like a local, I could append to a file, but more interestingly, deliver it by post method to a server or a port. And then a service is not a discrete look at inscription data. It's actually an ongoing service for, you can think of something like production. So this is going to be like a set and forget Ordhook service. And then my Ordinal app, this is just a way, this will make sense in just a moment. I wanted to just motivate like what looking at some of this data might feel like. So the first thing, and I copied a few of my, there we go, a few of my commands, is when so I've already installed Ordhook. I've also downloaded a local copy of, from the Hiro archive, some inscription data. I could do it manually with Ordhook. It could create its own index of inscription data. But Hiro maintains also archives to speed up that process. And I'm going to show you a scan blocks command. So I'm going to enter 2 blocks. And for some of you, you might recognize this 767. These are 2 auspicious blocks. I don't know if anyone speaks in block height, but the left block, our starting point, 767430, is the contains the Genesis inscription, sometime around middle of December. And then that right-hand block is just a few days later, or like a week later, and it includes the second inscription. So these are the first 2 inscriptions that Casey Rodimer inscribed. And a mainnet flag, just to show you that I'm working with the mainnet. And if I scan this, you'll see that Ordhook really quickly returns just some high-level information about these inscriptions. Great. But I want to work with this like programmatically. Oh, and actually just one more thing. I could also look up inscriptions by inscription ID. And so this is, again, the Genesis inscription, and you see here some metadata about it, like transaction history, et cetera. But I want to maybe like build applications. Let's say I want to do something that's currently the rage in Ordinals theory, and it's building Meta protocols. Who here has heard of a meta protocol? Does that name sound familiar yet? BRC20. Has anyone heard of a BRC20? That is an example of a meta protocol. It's a way of building more conventions and kind of more like layers on top of the base layer of Ordinals theory. So say that I want specific inscriptions that conform to a couple of standards, and then therefore they're BRC20s, or I want to work with a subset of BRC20s. I want to make a new social token or whatever. Working with these meta protocols and like further and further refined subsections of Ordinals data is like what Ordinals development often consists of. Okay, working with this data can be really, really hard, and Ordhook, as I'm about to show you, can make it a lot easier. We're going to just briefly look at what it might take to create a custom view of inscription data to look at, say, refine all inscriptions down to just BRC20s. Which, by the way, right now there's a ton of APIs out there that do this for you, but you have to wait for these API providers to spin up those services, do the interpretation work, build up performant databases so that you can get your data. That could take a while. And what if you are developing your own custom meta protocol, and no one's going to make this for you. No company's going to spin up these services for you, so you have to do it yourself. Well, with Ordhook, you can do it. Okay, so I showed you these two manual commands, and now what I'm going to do is I'm going to actually take a look at the payload underneath this Ordhook with this command. I now started a server. You'll see here that I have also just a really simple, this is our grand finale. I don't want to show that yet. Just a super simple script that is just going to, at first, show us this raw data, localhost 3000. So if I go to events, we'll see here that there's nothing shown here. Again, this script that I showed you is just I'm going to dump JSON files into it. And then I'm going to do my first command with Ordhook. Again, the same exact command. Let me change these blocks to 78726. I think it's 787.784.800. Okay. I'm pointing to a configuration path that has just some settings around networking between my Ordhook and my Bitcoin D instance. And then here's this flag, post2. So now I'm going to deliver whatever is found to this endpoint. And I have a couple of triggers. And if I were to go to my server, you'll see here, okay, a lot of random stuff that's kind of hard to scrutinize. But it looks, if you look a little closer, it looks, and I'm just going to pause it and actually kind of reduce the scope to, excuse me. I'm just going to restart this because I just want to look at like one or two events, not a ton. Okay, there we go. So I just looked at 2 blocks worth of inscription data. And again, this is a lot. And as a developer, I just want to know what's interesting. So I want to know, like, if I just want to look at times in which an inscription is revealed. I'm seeing, okay, Ordinals operations, inscription ID. Okay, here we go. Inscription revealed. This looks more relevant. Content bytes. Oh, wow, there's that long hex code that contains the actual underlying data. That looks important. Okay, so what I could do as a developer is decide I want to narrow down on this data. So what that might look like is doing some sorting of just working through a JSON object and narrowing it down. Okay, you can see here that I'm basically looking and pushing only those operations that have inscription revealed as a field. So if I go back, I restart my server, and then I run the exact same scan command, and I go back, I should have a refined view of my data, and sure enough, I have. And if you're not familiar, this is actually exactly how all APIs, as we kind of commonly know them, accessing blockchain data, this is how this interpretation layer works. We're looking at raw data. We have 520 gigabytes of blockchain data. We don't need all of it for our meta protocol. So I want to look at finer and finer views of our blockchain data. This is exactly what Ordhook makes possible. OK, I want to go even further, and I want to find BRC20 events. OK, now the actual decoding and encoding and looking for where it is in the inscription field that they are indicating what kind of inscription meta protocol this is a combination of research, looking at the Ordinals theory handbook, and looking at I forget a non-user who made BRC20s, but they make this convention out there, and then people start making these inscriptions. You can then convert that understanding into an interpretation layer, and let's see what this work here does. If I restart my server and make the exact same scan, now mind you, with this new I call it view number 3, and I make this run, and I go back to my server. Oh, I didn't save it, excuse me. But again, you can see just how quickly this is being done. Okay. Oh, did I not? Oh, I have to uncomment this as well. Excuse me. All right, one more time. And with that, I have from 2 relevant blocks, what is that? 6 actual inscriptions that really matter to me in my meta protocol. And they are BRC20 mints. The ticker is Soil. Soil is a BRC20 token. And here you can see that just in a matter of, well, I mean, that making that blockchain data view, that JavaScript, I'm just parsing JSON objects, took maybe like 20, 30 minutes one morning. So this is like for developers. This is for folks that are working in JavaScript. And I'll tell you, you don't need a whole ton to get started. There are people who are doing this who are just using ChatGPT and working with the little bit of JavaScript that they know and have. But this is how you can start actually building meta protocols, and then not relying or waiting upon people to provide custom views. You can create the custom view on your own for yourself, and you can spin up a new game, a new social token, what have you. I know we have a couple people in the room who've actually made BRC20 games. So okay, and now, and as a case in point, the remainder of this presentation, I want to just show you exactly what it is like that Hiro has done with Ordhook. Ordhook powers all of our Ordinals tooling. So not only this open source software that you all can use and download right now, if you just go to Ordhook at Hiro Systems, you'll see all of our instructions. This presentation, the kind of core of it, is from this piece of documentation that I published just a few weeks ago. Then we have the Hiro archive, which, again, you can spin up your own index of inscriptions, or you can get started with some of these larger files that Hiro archives, and then you can validate on your own back at home, because data sovereignty is something that our open source software supports. If you don't want to trust any third-party data provider, you can go ahead and verify all this on your own. And so this is, and let me just copy this. This is probably our most popular tool that uses Ordhook. It is the Ordinals Explorer that Hiro runs. Now, it is actually, there's an intermediate layer between Ordhook and our Ordinals Explorer, the Ordinals API, which, again, is an open source set of interpretation layers so that you can spin up your own Ordinals API if you so like. Hiro is really about open source software. And we used all of that to make here Classic Explorer. Here I'm entering the Genesis inscription. And all of the information that you might expect is here. I think the thing that's most special about the Hiro Explorer is, again, its reorg resistance. So all throughout the spring and summer, Bitcoin reorgs were happening. Again, if you just walked in, these are the blockchain phenomena where there's not, the network has not converged on a chain tip. Sometimes like two or more blocks are mined simultaneously, and which is the canonical chain tip. The way that Ordhook handles that is by providing rollback data alongside what it sees as valid data. So if at any time there's a Bitcoin reorg that happens, your application will be handed, oh, you hear blocks that you need to roll back, and here's the actual valid information. So you can build in whatever kind of reorg resistance or like data updating on your side. We provide that data for you, and that is why the Hiro's Ordinals Explorer is reorg resistant. It doesn't go down for hours at a time. Here is and if you look at the bottom, this is powered by the Hiro Ordinals API, and we have just all manner of endpoints that you would expect. There's also a executable demonstration panel so that you can actually experiment with this API by including block heights, etc. The BRC20 set of endpoints is the newest one. We encourage folks to check those out. Again, Hiro provides performance scalable APIs, everything you would want from a service provider. And then the last point I want to make is that the Ordinals API and the Ordinals Explorer, so this Explorer website that you're looking at, it just disappeared. This is actually built on open source software, the API and the Explorer. So if you aren't satisfied with just making custom views of your data that are kind of like raw and like I showed you, I just dumped them onto like a web page and rendered them in HTML. If you want to actually look at your custom inscription data views using our Explorer, you can go ahead. This is software that Hiro maintains, and you can have everything that I just showed you. You can do on your local machine, and if all that work in setting that up isn't to your liking, you can visit our APIs and use our APIs. And I do believe that there are rate limits on some of the endpoints, but just a short email away from actually opening up to whatever usage it is that your application would need. All right, and I think I do have one more slide. That this is open source software. Sometimes you might see, we love your comments and feedback, truly. And then this last point I want to make. So the Ordinals API, like Hiro as a service, is good for most use cases and most popular inscription types and most popular meta protocols. Good for production. You don't want to have to worry about standing up and maintaining servers. And good for scale. Ordhook is good for custom views of blockchain data that no one else is going to provide you. It's good for iteration. You saw how I was able to quickly test theses around like, okay, well, this is what I want to see. I want to narrow down on this. It took a matter of minutes. And it's good for data sovereignty and self-hosted approach. This stuff is open source, so you can validate exactly what's coming to you and know that it's valid and as true as the blockchain underneath it. And not meant for high volume scaling, so you might want to do some work in scaling there. With that, I'm all done, and you can check out our website at hiro.so. Thank you, everyone.